Hello everyone, my name is Mickey and today I'm going to explain you this question, which is question number 11 on LeetCode container with most water brute force approach. So we are going to write the code for it. I have already discussed the approach. I will link that video inside the I button. You can watch that from there. Okay, you can watch that video. I'll put the link there, or you can find that video in the description box. So let's get started. So this is the visualization of the container with most water. How does it look like in visualization form? Okay, this is the visualization. Okay, so we are given with input heights. Okay, these are the heights and these are the heights. These are the n vertical lines. These are n vertical lines that is placed inside the graph in order to form the container like structure. So these are the containers. So these are the heights. You can see these are the heights and these are the indexes value. Okay, so this is the water contained inside this container. So we have to return the maximum area of water. So max area water is returned by this container. This graph or this heights vector is 49. We have to return an output of 49 for this heights vector. So how we are going to calculate it, I'm going to tell you in this video through code. So we are going to write the code for this approach. I've already discussed the approach in my previous video. You can watch that video from the description box. I'll put the link in the I button. Next, we're going to write the code for it. We're going to make the function which is integer max water, and it will take the input as vector of integer and pass the heights vector. Next, inside this function we are going to make a variable which is integer max water and set it to 0. Max water container, I'm going to give it the name. Okay, next we are going to take the help of a loop which is starting from initially I equals 0, I less than n and I plus plus. So we have to initialize an n variable in order to get the height. So integer n equals heights dot size. Okay, why I'm taking this, I'm going to tell you. So, and this is the size we are getting from the size function which is stored in the n variable. Okay, that is why I have taken the help of n to get the size of this height vector. Next, I have taken the initially my boundary starts from this fact. So we are going to set the boundary which is I from 0th index. Next, we are going to start the second boundary which is j boundary, which is the right boundary. This is the left boundary. We have started the right boundary, left boundary from 0th index, which is I. Now we have to start the j boundary from, which is the right boundary initialized by j from I plus 1 value. Then only it will make sense to make a container. We are going to set the inner for loop starting from integer j equals I plus 1, j less than n and j plus plus every time. Next, we are going to get the width. How you will get the width, I am going to show you from this graph. So if you are setting this boundary, let's take the help of this boundary. So if this is I and this is j. So x-axis joins this container. Okay, x-axis is joining this container. So you will get the width by subtracting this index from this index value. If you subtract 4 from 2, you will get the water contained inside this container. You will get the width. So 4 minus 2 is 2. So width you get as 2 for that container. So like that you have to write the formula for it. Width is equal to j minus I. I hope this logic is clear for you why I have written this statement. I have already showed you in the graph. Next integer we are going to take heights. We are going to get the height of the container. So height is decided by, let me show you the same example. We are taking this 2 bar. If this is j and this is I, so I is having the minimum height, smaller height than this bar. So this I will be picked up as the height because this bar is controlling the water. If the water is coming out of this bar, the height increases, the water is going to spill out. That is why this bar is controlling the height. That is the reason we are taking the minimum value of the height of I and j. So minimum value of heights of I and heights of j. I hope this statement is also clear for you why I have written this statement. Next, we are going to get the current water. Current water equals width into multiplied by height. Whatever width you get and whatever height you get, that will be the current water for that container. Let me show you what I mean by that statement. So if we are taking the help of this container, so what will be the width? Width will be this. If this is I and this is j, width will be 3 minus 2, which is 1. So width will be 1, and the minimum height bar is this one, so 1 into 3. This will be the water contained inside this container. So this will be the current water for that particular container. Okay, I hope you are clear with this example. For that particular container, you are multiplying the width with height. Now you have to get the maximum water and store it in that variable. We have already initialized the max water, we don't need to reinitialize it. Just we need to store the maximum of current water which you are getting from the current container, and max water which was previously initialized. Any one of them, if current water is maximum or max water is maximum, that value is going to be stored in the max water variable, and we need to return it from that function. We need to return max water from this function. Okay, I hope this logic is clear. So inside the main function, we are going to call that function and store the results. Integer heights. Okay, I'm not going to take integer heights, sorry. It is a vector of integer heights equals, what is the value given? Let me see it. 186,254, 186,254, 186,254 and 54837. It is 837. So this is the height vector given, and we need to call that function. So we'll store the result in integer result into max water container and pass in the heights vector, and we can print the result, the console also. It will print the result, which is the maximum water that we get is 49, and we can return 0 from this main function and the function. So this is how we get 49 max water. I hope this code is clear to you. If you like the video, then you can share it with your friends and subscribe my channel for more. This was all about how to code the brute force approach. This is having a time complexity. If you take a rough look, this will also go up to n. So, and this will also go to n. So the time complexity of this function is also time complexity time complexity is O of n square, and space complexity is O of 1. We have not initialize any auxiliary space, extra auxiliary space. Space complexity is O of 1, and the time complexity is O of n square. I hope this logic is clear. See you in the next video. Like and share for more. Bye bye.